So in this part, I would like to talk about another astronomical concept, which is called the precession of the equinox. So when comparing to some other astronomical concepts that we have gone through in some other parts of this chapter, like the tropical year, moon phases, I would say that the precession of equinox looks to be a minor concept. But at the end, when we are talking about calendar making, measurements, so we cannot miss out any detail. We need to have everything to be very accurate in order to come up with the most accurate calendar. So that's why, even for the ancient Chinese people, they won't miss out this little observation. So we may have heard about the concept of precession when we are playing around the spinning top. So besides the self-revolution of the spinning top, we'll see about the rotational axis. The whole spinning top itself is also actually spinning. So there are two different kinds of motion. So actually it's a very common phenomenon for any kinds of spinning object, including our Earth. So our Earth is spinning in the middle of the space, orbiting around the sun, and the self-rotation is one kind of the motion, but there is some disturbances or vibration. So you will see that the rotational axis, so that means the way the Earth spinning, okay, is actually changing a slightly little bit. So it's an exaggeration in the photo, but actually the degree of precession or the degree of the disturbances is very, very little, as it's extremely difficult to observe. And we found that the ancient Chinese people know about that. So in AD 85, it was recorded that Jia Hui announced that the winter solstice point was 20.25 degrees away from the constellation Sagittarius. So that means it was a starting for the astronomer using some constellation as the reference point to measure our relative position of the Earth. So with this kinds of reference, so it was not until the AD 330, you see affirmed that the existence of the variation of this little angle. And he has even observed that there's a pattern within this variation. So he discovered that the precession rate should be 1 degree for every 50 tropical years. So if we exchange this number to a more intuitive concept, he's saying that the Earth will be taking 18,000 years to complete the precession cycles. Actually, this 18,000 year is not that bad number, because after some time, in the modern time, if we measure it once again with higher accuracy, better equipment, we find that the more accurate number should be 26,000 years. So at least the ancient Chinese people have got the correct orders of magnitude. Then in AD 604, Liu Zhuo updated the rate and set it at 1 degree for every 75 tropical years. So you see the effort from the people to refine this kind of number. And eventually in AD 1199, in the Tongtian calendar, so they have adopted a more accurate data, which is 1 degree for every 66 tropical years and 8 months. So you see about the efforts for refining this number in order to make a more accurate calendar.